In this tutorial we will cover chapter 1, which we will mostly consider linear equations and rational equations. To start with, we will start with linear equations. A linear equation in one variable is an equation that can be written in the form ax plus b equals 0. Here x is a variable and a and b are real numbers. The leading coefficient a, the coefficient of x, cannot be equal to 0. Here is a quick example. The equation 2x plus 3 equals 0 is an example of a linear equation. The reason they are called linear equations that if you graph these equations you will get a straight line. How to solve linear equations if you have an equation in one variable. Here are the general steps to solve these equations. The first step is to simplify both sides of the equation. Simplification may involve division or multiplying, but that's the first step, is to simplify both sides of the equation. Collect the variable terms to one side, and the terms that have the variable, we keep them on one side, and then the constants, which are the numbers, on the other side. You can apply multiplication or division to obtain the coefficient of one on the variable. You want the solution is a value for a variable, so you want to end up with the variable equal to some quantity. Check for potential solution. Of course, after you find the solution, you can always try to substitute it in the original equation and see if it does solve the equation. Here is an example of solving linear equations. We want to solve minus 2, then brackets x minus 3 plus 5x equals 12. The first step is we want to simplify the left hand side. Multiply minus 2 by the bracket, you get minus 2x, then we have minus 2 times minus 3 is just plus 6, plus 5x is equal to 12. Next we add minus 2x with 5x to get 3x plus 6 equals 12. Now subtract 6 from both sides, you get 3x equals 6. Divide both sides by 3, you get x is equal to 2. Then x equal 2 is the solution for the original equation, and the solution set has just the number 2. Of course, if you want to check whether your solution is correct, you can always substitute the value for x. Substitute 2 for x in the left hand side, you should get 12, and 2 should solve the original equation. Now whether we have a solution or not, there's different types of equations. One type is called the conditional equation. That means that has a solution. Yani it is true for some values of the variable but false for the others. A contradiction is a type of equation that's false for all values of the variable. In other words, it does not have any solution. The third type is an identity, which is an equation that's true for all values of the variable. The other type, we will consider also the rational equations, and the idea of solving rational equations is by multiplying both sides of the equation by the least common divisor of all fractions in the equation. Using this step would simplify the equation, and we can a rational equation, and then we can solve it. Here is examples of the different types of equations. 2x equals 16. This is a conditional equation. And the solution, if you divide both sides by 2, you get x is equal to 8. The solution set has only one number, which is 8. Generally, if you have a solution for a linear equation, there will be only one solution. This is a conditional equation because it is true only for x equal 8. Of course, it is false for any other value for x. An example of a contradiction is 2x plus 1 equals 2x plus 3. This is a contradiction because this statement is false for all values of x. This equation has no solution. The solution set is empty. An example of an identity is the equation 3x plus 6 equals 3, then brackets, 3 times x plus 2. This is an identity. It will be true for all real numbers. Let's look at a rational equation and see how we can solve it. The example we have here, the left-hand side is 4 over y equals 18 over 3y plus 1. Here the least common divisor of y and 3y is just 3y. And if we multiply both sides by 3y, that should simplify the expression. Again, remember, with an equation, if you multiply one side by anything, you have to multiply the other side so that you don't change the equation. Now for the left-hand side, if you divide by the common factor, and just cancel the common factor, so you end up with 3. The y cancels, the y from 3y cancels with the y in the denominator. You're left with 3, so you're left with 3 times 4, which is 12. That's the left-hand side. For the right-hand side, you have to multiply 3y by 18 over 3y, and also multiply it by 1. 3y times 18 over 3y, if you cancel the 3y, you are left with 18. 3y times 1 is just 3y. Next step, subtract minus 18 from both sides. The left-hand side is just 12 minus 18, which is minus 6, equals 3y. Divide by 3, you get y equal minus 2. And that's your solution. The solution checks. You have here a conditional equation because it has one solution. Again, you can always check to see if the solution works. In this case, you have to substitute y equal minus 2 in the original equation, and you should have the left-hand side equal to the right-hand side. Section 2, we will look at applications using linear equations. Of course, as we did before, modeling with linear equations, that means you use a linear equation to describe a real-life situation or to describe a physical situation. Of course, the model, in the end, you would want to set up your model so that you have a linear equation, and then you can solve the linear equation. There are general guidelines that you can use to solve equations or to solve applications. To convert a real-life situation into a mathematical equation, you need to read the problem carefully and assign variables to unknown quantities. Normally, we are working with variables. You can give them names. Anytime you have an unknown quantity, you can assign it a variable. Sometimes it would help to use a table to summarize your information. You can, whatever available information, you can label the given information, or whether to summarize it in a table or to use a figure. In the end, your goal is to find an equation. That's step number 3, is to write an equation that represents the model that we have. Once we get to that stage, then we can solve the equation from step 3, and that would give you the solution. You can interpret the solution and check to see that the answer is reasonable. Let's look at an example of a linear model. let's just see what we want to do, and then in this case we will use a table to summarize the information. We want to know how much of a 20% acid solution should be mixed with 400 milliliters of a 5% acid solution to bring the concentration rate up to 10%. A 20% acid solution, that means 20% of the liquid is acid, and then 80% would be just water. So we don't know how much we need of the 20% solution, so this is the quantity that you should assign a variable. We will use x. The other solution, we already know the concentration, it's 5%, and we know the volume, but we just want to know how much of the 20% acid solution we need to add to the 400 milliliter of 5% acid solution. We want the resulting mixture to be 10%. Here is the first step. طبعا how much, this is the unknown quantity. This is x, then represents the amount of the 20% solution that we need. In this case, of course, we are adding this x, this unknown quantity, we're adding it to 400 milliliter. For the size of the mixture will be 400 plus x. This is we want that to have 10% concentration. So here is a table summarizes the information we have. The first solution, the 20% solution, we don't know how much we need. That's x. For the volume of the mixture, that's the 20% solution is x. Since this is a 20% solution, then the amount of acid in this solution will be 20%, or 0.20x. The second solution, we know the volume, 400 milliliter, and we know the concentration is 5%, so the amount of acid is 5% of 400, or 0.05 times 400. The resulting mixture, now we already said the volume will be 400 plus x. The amount of acid, since this is a 10% solution, it will be 10% of 400 plus x, or 0.10 times 400 plus x. And once you have this table, now you can set up your equation, and it turns out it will be a linear equation. We know that the sum of the acid, if you take the acid in the first solution plus the acid from the second solution, that should give you the acid in the mixture, the resulting mixture. For the acid from the 20% solution plus the acid from the 5% solution should equal to the acid from the 10% solution, the resulting mixture. So we have now 0.20 times x plus 0.05 times 400 is equal to 0.10 times 400 plus x. So this is your linear equation. We need to simplify it. You simplify it by multiplying 0.05 times 400. For the left hand side will be 0.20x plus the product here is 20 equal the right hand side, multiply 0.10 times 400, you get 40 plus 0.10 times x. Now subtract 0.10x from both sides and subtract 20 from both sides. You end up with 0.10x is equal to 20. Now your solution, you get your solution by dividing both sides by 0.10x. Your solution is x equal 200. That means you need 200 liters of the 20% solution to add to the 400 milliliters of the 5% solution, to get a mixture that is 10%. The mixture, the volume of the mixture will be 600 in this case. If you want to check your solution, of course, you can substitute. Here is your model, here is your equation. You can just check out the amount of acid in each of the two solutions, and also the amount of acid in the mixture. They should be the same. 0.20 times 200, which is the first mixture that has 40 milliliters of pure acid. The second solution, the 5% solution, will have 0.05 times 400, which is 20 milliliters of pure acid. The mixture, which is the volume is 600 milliliters times 10%, is 60 milliliters. So it checks, yani the sum of the pure acid from the two solutions add up to the amount of pure acid in the mixture. Next, we will cover section 1.3, which we will be studying what's called complex numbers. So far, all the numbers we worked with are real numbers, but real numbers, we will find out that some equations have no solutions, no real solutions. The complex numbers is an extension of the real number system. So these numbers are not real numbers. This is something we add to the real numbers. In the new system, now we will have solutions for more equations. The idea is for us to introduce the new numbers is define a new number. We will call it I. I is equal to the square root of -1. We know that the square root of -1 is not a real number. The square root is not defined for negative numbers, so the result of taking the square root of -1 is not a real number. This is our new number. For I, by definition, is equal to the square root of -1. The next thing we can do, what do we know about I? Well, for one thing, we know it is not a real number. Also, if you take I squared, if you square the square root of -1, you end up with -1. This is now the building block for all complex numbers. The number I is just the square root of -1, and of course that means that I squared is equal to -1. The second equation will also tell us that this number I is not a real number, because for real numbers there is no real number that you can square to get a negative number. But this works for I. Our new number, I is equal to the square root of -1, is an addition to the real numbers that will enable us to solve more equations. Now, what about if you have the square root of -b? If b is a positive number, what happens if you take the square root of -b? Well, this is the same as the square root of -1 times the square root of b, which means you can write it as I times the square root of b. For example, the square root of -5 is equal to I times the square root of b. Of course, this part is real, but it's multiplied by I, so this is a complex number. Now, the general form of complex numbers would be you can write any complex number in this form: a plus bi, where a and b are real numbers. Any real number, any complex number can be written as a plus b times I, where a and b are real numbers. Now, with this format, you can think now of any real number. You can think of it as a complex number. If you just set b to equal to 0, for any real number, a can be written as a plus 0 times I. It should be clear that any real number can be thought of as a complex number. The complex number system is an extension of the real number system, where you think of the real number system as a subset of the complex numbers. If you write a complex number in this form, a plus bi, where a and b are real numbers, a is called the real part and b is called the imaginary part. And we will see how we can add and subtract complex numbers. The way to do that is you combine the real parts, and you add them together, and also combine the imaginary part. And you always try to write the number as in the format a plus bi, but it should be easy to add and subtract complex numbers. Also, to multiply, you can work with complex number. The multiplication should also be easy. For example, the square root of -9 times the square root of -16. We can write this number. The square root of -9 is the same as I times the square root of 9, so you can write it as 3i. The square root of -16 is just I times the square root of 16, so it's just 4i. Now when you multiply these two numbers, multiply the real part. 3 times 4 is just 12, and I times I is just I squared. And remember, I squared is equal to -1, so you end up with 12 times -1, which is -12. So the product of these two complex numbers is the number -12. Here is an example of a complex number written in the standard format. If you write 3 plus 8i, this is a complex number. The real part is just 3, and the imaginary part is equal to 8. And here is an expression involving adding and subtracting complex numbers. The first number is 4 plus 7i, minus the second number is 3 plus 6i, plus the third number, which is 2 plus 10i. What you want to do is combine the real numbers of the real part of each number. You can combine it together, and also combine the imaginary part for all three numbers. If I take 4 minus 3 plus 2, that's the real part, and then plus the imaginary part, 7 minus 6 plus 10, that's the imaginary part. 4 minus 3 plus 2 is just 3, plus then the imaginary part is just 11. The sum of 7 minus 6 plus 10 is just equal to 11. Now, to multiply complex numbers, you can do this by using the distributive property. And here is an example that would explain multiplication. Multiply the first number 1 minus 4i times 2 plus 3i. Of course, multiplying these two expressions, you want to multiply each term from the first bracket by each term from the second bracket. 1 times 2 is just 2, plus 1 times 3i is 3i, then minus 4i times 2 is minus 8i, and minus 4i times 3i is just minus 12i squared. In the next step, we want to add similar terms and replace I squared by minus 1. 3i minus 8i is equal to minus 5i, and the I squared will replace by minus 12. The next step, multiply minus 12 times minus 1, you get plus 12, and then add 2 and 12, you get 14 minus 5i. The product of the two complex number is another complex number. You should always write the results of calculations in the standard form. Now we will look at division of complex numbers. The division would involve a rational expression. What you want to do is to simplify the expression by multiplying the numerator and the denominator by the conjugate of the denominator. Of course, the conjugate here for any number a plus bi, the conjugate is the same number but just change the sign. The conjugate of a plus bi is just a minus bi. This type of product, one of the formulas we considered in chapter 1, this product will give you the square of the first number a minus the square of the second number, which is bi. You get a squared minus the square bi. Now you get b squared I squared. I squared can be replaced by minus 1, and minus 1 times minus b squared will be plus b squared. The product of a complex number with its conjugate is always equal to the square of the real part plus the square of the imaginary part. So the product here is actually a real number. And this formula is useful to when we work with division, when we work with rational expressions, by multiplying by the conjugate of the denominator. That should simplify the expression, and you can carry out division in this case. Let's look at an example. Here is a rational expression involving complex number 4 divided by 3 plus 5i. What you want to do is multiply the numerator, the top part, and the denominator by the conjugate of the denominator, and the conjugate here being 3 minus 5i. You have to do this, you have to multiply both the numerator and denominator. Starting with the numerator, this should give us 4 times 3, which is 12. Then 4 times minus 5i is minus 20i. The denominator now, you are multiplying a number with its conjugate, so the result should be the square of the real part plus the square of the imaginary part. The result now for the multiplication is 12 minus 20i divided by 9 plus 25. Now you want to write this in the standard form. The sum here is 34 in the denominator, so you can write it as 12 divided by 34, then minus 20 divided by 34 times I. This form, the final result, is 6 over 17 minus 10 over 17 times I. This is written in the standard form. Next, we would like to study quadratic functions. This is section 1.4. Quadratic equation is an equation of the second degree. So it's an equation involving one variable x, and it has the form a times x squared plus bx plus c equals 0. And here the leading coefficient, the coefficient of x squared, cannot equal 0. This is a second degree equation, or a quadratic equation. Now these are relatively more difficult to solve. We want to consider two properties that will help us solve quadratic equations. The first one is called the zero product property. If you multiply two numbers and the result is equal to 0, then one of the numbers must be equal to 0. If m times n equals 0, then either m is equal to 0 or n is equal to 0. This is something we know about real numbers. Whenever you multiply two numbers and the result is equal to 0, then one of them must equal to 0. The second property that we will use to solve equations is called the square root property. If x squared is equal to k here is a positive number, then x is equal to minus or plus the square root of k. That means this equation has two solutions: square root of k and minus the square root of k. This is called the square root property. We will use both properties now to solve quadratic equations. Let's start with example 1. We would like to solve the equation x squared minus x minus 12 equal to 0. The first step is to factor these expressions, and we did study factoring in chapter 1. You can factor this equation to the product of the two factors x minus 4 times x plus 3, that's equal to 0. You can always check if you multiply those two terms, you should get x squared minus x minus 12. Now that's the first step to solve the equation, is to write it as the product of two terms. Now you can apply the zero product property. You have two brackets, their product is equal to 0. In this case, then, by applying the zero product property, one of the brackets must equal to 0. Either x minus 4 equal to 0 or x plus 3 equal to 0. In the first case, if x minus 4 equal to 0, then add 4 to both sides, you get x is equal to 4. So this is my first solution. In the second case, if x plus 3 equal to 0, then subtract 3 from both sides and you get x equal minus 3. And that's my second solution. The solution set now will have two numbers, 4 and minus 3. طبعا again, these being solutions to the equation, if you substitute, to check the solutions, if you check for x equal 4, if you substitute x equal 4 in this left-hand side, the left-hand side of the equation, you should get 0. The same thing for x minus 3. If you substitute x equal minus 3 in the original equation, you should also get 0. Both of these are solutions. Let's look at an example where we use the square root property. Here we want to solve x minus 3 squared equal to 5. In this case, then, since the square of x minus 3 is equal to 5, then x minus 3 must equal to minus or plus the square root of 5. طبعا to get a solution, we want to know the value of x. Add 3 to both sides. So the solution now is x is equal to 3 minus or plus the square root of 5. This is actually two solutions. طبعا one solution you get if you take 3 plus the square root of 5. This is one solution. And the second solution is 3 minus the square root of 5. So again, here you have two solutions. The other method to solve quadratic equations is called completing the square. And try to write the equation as a square of something and then apply the square root property to find the solution. Again, we are trying to solve a quadratic equation. Ax squared plus bx plus c equals 0, and a does not equal 0. The steps that we need to complete the squares are as follows. The first step is to divide both sides by a to make the leading coefficient equal to 1. طبعا a being the coefficient of x squared. So you want to divide both sides by a because you want the coefficient of x squared to equal to 1. But then isolate the variable terms to one side. For example, leave anything that has x or x squared, leave it on the left hand side, and then the numbers can be taken to the right hand side. Complete the square. Here is the step that you have to do to complete the square. You add the square of 1/2 of the linear term to both sides. That means take the coefficient of x, divide it by 2, then square the result and add it to both sides. Once you do this, you will have the left hand side now will be the square of a bracket. Then you will have a perfect square trinomial. You can apply the square root property to solve for x. Of course, just reading the steps will be clear when we apply those steps to a particular problem, and that's what we will do in the next slide. We want to solve this quadratic equation using by completing the square. The equation is 2x squared minus 8x minus 16 equals 0. The first step is to divide by 2 because we want the coefficient of x squared to be 1. Dividing by 2, that means you divide both sides by 2. To divide the left hand side by 2, you have to divide each term by 2. 2x squared divided by 2 is just x squared. Minus 8x divided by 2 is minus 4x. Minus 16 divided by 2 is minus 8. And the right hand side, 0 divided by 2 is equal to 0. The next step, we want to isolate the variable terms. We can leave the x squared minus 4x in the left hand side, and the minus 8 you can take to the other side, it becomes 8. And you notice we leave a space because we'll be adding, you leave a space on both sides because we'll be adding a number to complete the square. But so far we have x squared minus 4x equal to 8. Now here is the step to complete the square. Take the coefficient of x, and take minus 4, divided by 2, you get minus 2. Square that, and multiply it by itself, you get plus 4. Then I need to add 4 to both sides. I end up with x squared minus 4x plus 4 equals to 8 plus 4. The right hand side is just 12, but by doing this step now I have a complete square, a perfect square. This left hand side now can be written as x minus 2, everything squared. The 2 here is just half of the coefficient for x. Once you get to this step, now you can apply the square root property to complete the solution. The square of x minus 2 is equal to 12. That means x minus 2 is equal to minus or plus the square root of 12. This is just applying the square root property. Now add 2 to both sides. You get x equal 2 minus or plus 2 the square root of 3. So again you have two solutions. 2 plus 2 times the square root of 3, that's your first solution. The second solution is 2 minus 2 times the square root of 3. The third method to solve quadratic equations is using the quadratic formula. Again, this is to solve a quadratic equation, ax squared plus bx plus c equals 0, and a does not equal 0. The solutions can be given by applying the formula. Your solutions will be x equal minus b minus or plus the square root of b squared minus 4 times a times c divided by 2a. Of course, a here being the coefficient of x squared, b is the coefficient of x, and c is the constant term. This should always give you the solutions. Of course, whether the solutions are real or complex depends on the discriminant. Yani the quantity under the square root, this is called the discriminant. It will determine the type of solutions and the number of solutions. So we have three cases. If the discriminant, if b squared minus 4ac is less than 0, then you have two complex solutions, two imaginary solutions. If b squared minus 4ac equals 0, then you only have one solution, which is a rational solution, minus b over 2a. The third possibility, if b squared minus 4ac is positive, then the equation has two real solutions. So here are the three possible answers. If the discriminant is negative, you have two complex solutions. If it's equal to 0, you have one rational solutions, and real solution. And if b squared minus 4ac is positive, then you have two real solutions. Let's apply the quadratic formula to solve an equation. We want to solve 2x squared minus 3x plus 7 equals 0. Here, of course, a is equal to 2, b is equal to minus 3, and c is equal to 7. Now, substituting in the quadratic formula, minus b is just minus 3, minus or plus. The square root of b is the square root of minus 3. Minus 4ac is just minus 4 times 2 times 7, divided by 2a, which is just 2 times 2. Now, if you simplify the discriminant, you will get minus 47. For the next step, your solution x is equal to 3 minus or plus the square root of minus 47 divided by 4. So clearly in this case you have two complex solutions. You want to write it in the standard form. You can write this as 3 over 4 minus or plus. Now the square root of minus 47 is just the square root of 47 times I. your final, the two solutions will be 3 over 4 minus or plus the square root of 47 divided by 4 times I. This is your solution set. You have two complex solutions. Now notice that the two solutions are actually conjugate of each other, and this is always true. Anytime a second degree polynomial or quadratic equation has a complex solution, then the conjugate will also be a solution. Complex solutions come in pairs. If you have one complex solution, then the conjugate will also be a solution. Example 5, we are not asked to find the solution, but at least to determine how many solutions we have, the number of solutions, and the type of solutions. For the quadratic function 4x squared minus 5x plus 11 equals 0. Here a will equal 4, b is equal to minus 5, c is equal to 11. We only need now to calculate the discriminant so that we can find out the number of solutions and the type of solutions. B squared minus 4ac is equal to minus 5 squared minus 4 times 11. If you simplify this, you should get minus 151. If the discriminant is negative, then we know we have two solutions and both will be complex solutions. Section 1.5, we will look at applications of quadratic equations. We can use quadratic equations to model applications, many applications. In particular, we will look at an application to study the motion of objects moving vertically under the influence of gravity. Of course, the object could be moving up or it could be moving down, but actually the position of an object moving vertically can be modeled using a second degree equation. Here in this application, the vertical position we denote it by S. The vertical position here means the height of the object. We are looking at objects that are moving vertically under the influence of gravity. The equation that describes the motion is S equals minus 1/2 g t squared plus v0 times t plus s0. Here g is the acceleration due to gravity at sea level. There is two types of measurements. If we use the metric system, it is 9.8 meter per second square. The other measurement, if you measure it in feet, the gravity is equal to 32 feet per second square. Depending on the problem, either use the meter per second square or feet per second square. These are units for the gravity. T here, the independent variable, represents the time after the start of the experiment, and after the motion starts. V0 is the initial velocity. S0 is the initial position. In this case, it will be height. And S is the position of the object at time t. The left-hand side, S, is the position or the height. The variable here, t, represents the time. The remaining constant is g, v0, and s0. These are normally given in the problem. G being the gravity, v0 being the initial velocity, and s0 is the initial height. Here is an example of using a second degree equation to describe motion. We have a diver that jumps approximately straight upward from a diving board 3 meters above the water with initial velocity of 5 meters per second. Then in the problem we're given that the initial height is 3 meters, the initial velocity is 5 meters per second. We want to write a model to express the height. Here, since the units are in meters, we want the height to be given in meters of the diver. For the model, of course, here that we started with, S is equal to -1/2 times G. G here we take the metric system units, 9.8 meter per second square, times T squared, plus 5 times T, since 5 here is the initial velocity, then plus 3. We want to simplify the equation, multiply -1/2 times 9.8. The model then becomes S equals -4.9 times T squared plus 5T plus 3. S is the height as a function of T, the time, is equal to -4.9 T squared plus 5T plus 3. In the second part, we want to know the time required for the diver to hit the water. Of course, the instant the diver hits the water, the height will be 0. So to find the time, we want to set the height to equal 0. In the equation that describes the motion, the height, set the height to equal 0 and solve the equation. The value for T is the time that is required for the diver to hit the water. Since this is a second degree equation, one way to solve it is to use the quadratic formula. The solution x is equal to -b, or -5, minus or plus b squared, which is 5 squared, minus 4 times a, which is -4.9, times 3, divided by 2 times a, which is -4.9. The next step, you want to simplify this expression. -5 minus or plus the square root of 83.8 divided by -9.8. You get two solutions. The first solution is approximately -0.42 seconds. We reject this solution because it's negative. Time cannot be negative. The other solution is 1.44 seconds. It will take the diver then 1.44 seconds to hit the water. That is, of course, after leaving the board. Section 1.6, we would like to look at more types of equations and looking at some applications that involves these equations. The first type we will look at is trying to solve polynomial equations. Polynomial equation means the one side will be a polynomial and the other side equals to 0. What we want to do is try to factor the polynomial so that we have the product of a linear, or either the product of linear factors or the product of a linear factor and quadratic factor, and then we can try to solve each factor separately using the zero product property. Here is an example. We want to solve the equation 8x cubed plus 125 equal to 0. Now the first step is to factor the left hand side using this is the sum of two cubes. You can think of 8x cubed as 2x everything cubed, and the first term is 2x cubed plus 5 cubed. So this is the sum of two cubes. Using the formula for the sum of two cubes, you can write this as 2x plus 5 times the square of 2x, which is 4x squared, minus the product, which is minus 10x, plus the square of the second term, which is 5 squared is equal to 25, and that is equal to 0. At this stage, you look at this equation. It is a product of two terms. The product of two terms is equal to 0. Then using the zero product fact, or what we have learned about the product of two things. If the product is equal to 0, then one of the quantities must equal to 0. So either the linear term is equal to 0, 2x plus 5 equal to 0, or the quadratic term, 4x squared minus 10x plus 25 equal to 0. And we have to solve these separately. In the first case, if 2x plus 5 equal to 0, then you can subtract 5 from both sides and then divide by 2. You get your first solution. X is equal to minus 5 over 2. Now the second two solutions, the other two solutions, you get from trying to solve the quadratic term. 4x squared minus 10x plus 25 equals 0. You can use the quadratic formula to solve that. Here a is 4, b is minus 10, and c is equal to 25. Substituting those numbers in the quadratic formula, you get your two solutions are x equal minus 10, minus b, minus or plus b squared, which is minus 10 squared, minus 4 times a times c, which is 4 times 25, divided by 2a, which is 2 times 4. This can be simplified. The discriminant can be simplified. You get minus 300. Your two solutions now become 10 minus or plus the square root of minus 300 divided by 8. Now you can write the square root of minus 300 as the square root of 300 times I, or you can write it as 10 times I times the square root of 3. The denominator is 8. Next, you want to write it in standard form. This is 10 over 8, which is just 5 over 4, minus or plus 5 times the square root of 3 divided by 4. This is just dividing by 8 and simplifying. So here is your two solutions that you get from the quadratic term. Plus you have a solution from the linear term. So you have three solutions. The first one is real, minus 5 over 2. The next two are conjugates, complex numbers, 5 over 4 minus or plus 5 times the square root of 3 divided by 4 times I. The idea here, of course, is we started with a quadratic term. We factor it, we write it as the product of a linear term and a quadratic terms, and solve each term, use the zero product property, set one of the terms to equal to 0, which is the linear term. That will give you one solution, and then when you set the quadratic term to equal to 0, you get your other two solutions. And in the end, you have three solutions for this third degree equation. Next, we would like to see how to solve radical equations, meaning an equation involving a radical expression. The steps to do this: first, isolate the radical. If an equation has more than one radical, you can choose one of the radicals to isolate. Then raise each side of the equation to a power equal to the index of the radical. This way that you can get rid of the radical. So if the radical, for example, is the square root of something, then square both sides. If it's a cube root, then you cube both sides. Then the next step is to solve the resulting equation. If the equation still has a radical, you can repeat steps 1 and 2. Finally, check for potential solutions in the original equation. So the solution depends on the type of radical. The idea is to try to get rid of the radical and end up with an equation that you can solve. Let's look at an example. Solve the cube root of x minus 1 plus 2 equals 6. The first step is to isolate the radical, so subtract 2 from both sides. You get the cube root of x minus 1 equals 4. Now the left hand side is a cube root, so you want to raise both sides to the power 3. For the left hand side, the cube root of x minus 1 raised to the power 3 equal to 4 to the power 3. The next equation, you have x minus 1 equal 4 cubed, which is 64. Now add 1 to both sides, you get x is equal to 65, and that is your solution. Now what about if you have equation that has the power is a fraction? For example, you have u equal, or u raised to the power m over n equal k. Now that depends on whether m is odd or even. Then you can either have one or two solutions depending on whether m is even or odd. In the case where m is odd, now you have the left hand side raised to the power m over n. To get rid of the radical, you want to raise both sides to the power which is the reciprocal of m over n. You raise both sides to the power n over m. For here, if m is odd, you will have only one solution. By raising both sides to the same power, you have u raised to the power m over n, everything raised to the power n over m equal k raised to the power n over m. Now for the left hand side, if you multiply the inside and outside powers, you get u, and the right hand side is just k to the n over m, and that will give you your solution. You have one solution because m is odd, so when you raise the power to the power n over m, when m is odd, you have only one solution. In the case where m is even, you do the same thing. You raise both sides to the power n over m, but now because m is even, you will have two solutions: minus or plus the right hand side k raised to the power n over m. For that's, you have to be careful whether m is even or odd. In the case where m is odd, you'll have only one solution. If m is even, you will have two solutions. Let's look at an example. We want to solve c raised to the power 2 over 5 equal to 4. Here m, which is the numerator, is odd, it's even, c to the power 2 over 5, 2 is even. Raise both sides to the power 5 over 2, but because m is even, which is 2, you will get two solutions: minus or plus 4 raised to the power 5 over 2. We have raised both sides to the same power, 5 over 2, and because m is even, you have two solutions: minus or plus, the right hand side raised to the power 5 over 2. Now again, here when you multiply the inside and outside power, you should get 1, c to the power 1. The two solutions are minus or plus. 4 raised to the power 5 over 2 is just the square root of 4, everything raised to the power 5. And there's two solutions: minus or plus the square root of 4 raised to the power 5. The square root of 4 is just 2, and 2 raised to the power 5 is just 32, so your two solutions are plus or minus 32. Let's look at another situation where you have an equation with powers which are fractions. Sometimes an equation, using the correct substitution, you end up with a quadratic form that you can solve. Let's see if we can solve the following equation: x to the power 2 over 3 minus 3 times x to the power 1 over 3 minus 4 equals 0. Now if you look at those terms, the middle term x to the power 1, 3, if you square that, you get x to the power 2 over 3. That should give us an idea for substitution. We can let u equal to x to the power 1 over 3. In this case, of course, x to the power 2 over 3 will be just u squared. U squared is equal to x to the power 2 over 3. For x to the power 2 over 3 becomes u squared minus 3 times x to the 1/3 is just u minus 4 equals 0. Now this equation in the new variable u is a quadratic equation. We can solve it by factoring. You can write it as u minus 4 times u plus 1 equals 0. Use the zero product property. Either u minus 4 equal 0 or u equal 4, or u plus 1 equals 0, which means u equal minus 1. طبعا we want to solve in terms of the original variable x, so now we substitute back, replace u by x to the third. This first equation become x to the 1/3 equal 4. Raise both sides to the power 3. You get x equal 4 to the power 3, which is 64. That's the first solution. For the second term, we have u plus 1 equals 0, which means u equal minus 1. Now substitute u equal to x to the 1/3. X to the 1/3 equal minus 1. Raise both sides to the power 3. You get x is equal to minus 1 raised to the power 3. X is equal to minus 1. So here is your two solutions. X equals 64 and x equal minus 1. طبعا يعني in this case we have two solutions, and you can always check solutions by substituting the solutions in the original equation, and you should يعني the solution should satisfy the equation.